Okay, excellent. So what I'm going to do is very briefly go over our new return on investment numbers that we have on the project that I mentioned yesterday. Always want to thank DOE for the grants. They gave us a grant for the original pilot study. Now we're in a 3-year grant program. The original pilot study itself, we tested 3 different approaches as far as figuring out the model and actually how the numbers would work in the whole thing. And this is a kind of innovative or different way of doing macroeconomic work. In most academic situations with macroeconomic modeling, you're taking fixed data sets and then modeling against it. What we're doing here is we're actually doing the raw data collection. So we're collecting all the raw data and we're working through the program. The background on this, for those of you who haven't seen the presentation before, we're creating 2 models. One of them is a macroeconomic model that depicts where you make an investment in HPC and then the outcome in revenue, profits, cost saving, and job creation. And the second one is you make the investment in HPC and then it's scientific innovation. And we're also making all of this information available to everyone. I'll show you a pointer at the end how you can pick up the pilot study, and in just a few weeks we'll have the new data posted there too. But you actually can get the spreadsheets where you can sort the financial things based on whether it's revenue, profits, or jobs by industry, country, organization size. And then on the innovation side, we've created 2 indexes now. One of them is based on the importance of the innovation, and the other one's based on the impact, and I'll show that in a second. And then also everything we're sorting now by these categories as far as the type of the innovation, whether it's for better products, making a scientific breakthrough, creating a new approach. And here are the 2 new innovation scales that we're using. I mentioned the importance factors is whether it was one of the top 2 or 3 innovations in a particular field in the last decade, going down to the, one of the top 50. And then the impact is how many organizations are impacted by the innovation itself. And the top scale right now would be useful to more than 10 organizations. And I love our bottom scale here of 1, and that is an innovation that's only recognized by experts in the field. So that's kind of the scale that we're using at the moment. And all these innovation models can be sorted whether it's a basic or applied research, and also by industry, sector, country, org size, and major sector, government, industry, and academia. The data set that we'll be posting real soon, we're doing snapshots. We haven't decided if we're going to do the snapshot every quarter, every 6 months, or so on. But the snapshot that this data is we took on July 30th, and it has 329 case study examples. Now, these are actually equivalent of 329 success stories in using HPC in different industries, different areas, and so on. Our goal is to get to 1,000 as soon as we can. We were hoping to do that by the end of this year. We're not going to hit 1,000 by the end of this year, but at least that's the trajectory we're on. And the financial ones, we have 114 and 215 innovation examples. So on the financial side, as I mentioned yesterday, the numbers have increased from the original study quite a bit. For every dollar invested in HPC in these success stories, $515 were generated in revenue. And for every dollar in HPC as far as profits or cost saving, it was $43 return. So just tremendous returns here. Here's the new model itself. If you download the file, it's an Excel pivot table, so you can sort it by the various industries at the top, country, and so on. This one I'm showing it's just sorted by sector. And you can see in the sample right now we have 1,793 new jobs were created just from these projects. I should mention what we're calling a project is not a whole computer like Doug, your Oak Ridge machine. Eventually we want to be able to do a whole center like you have. That's not going to happen until we're 3 years down and we have to do a lot of other things. This is measuring each project done on an HPC system. So that's what one case study or element is. Here's the similar results from the pilot study. As I mentioned, the numbers went up quite a bit because in the pilot study we were at 356 and 38, and in the new one we're at 514 and 43. So continues to improve. The reason we're striving to get to 1,000 is we think we need roughly 1,000 for 2 things. One is to have more stability in the numbers, but to allow us to do a lot more sorts. And I'm going to show you some examples of the sorts, and you're going to see the data is a little thin for some of them. So in this case here, it shows it by industry. And we're including academia here. And you can see in some of the cases here, our sample size are too small to make meaningful comparisons by industry. But there's some interesting trends here. My favorite one is transportation. I never would have guessed that transportation has one of the highest returns. There's 2 factors to that. One, the transportation industry tends to use kind of small machines. So their HPC investment is low. The other part is the return is just staggering. This is primarily the traveling salesman problem. It's optimizing fuel consumption, on truck systems, airplanes, and so on. And no surprise that the financial sector is very high and oil gas is quite strong. On the job creation side, which DOE has asked to split out more details, I only have one chart at the moment. But as I mentioned, the number of sites, jobs created were fairly high, and the average investment in HPC per job created was only $200,000. So it wasn't an extreme amount required in that case. So then I'm going to flip gears, because I'm trying to stick to the 15-minute time period, to the innovation side of the models. So this is still looking at the financial examples, but putting them in the innovation categories. So this is the 114 examples. It's no surprise here that better products are the primary area for financial return, but also creating a new approach is a key one. Same layout, but these are now for the innovations, the 215 scientific innovations. And here, creating new approaches become much more important. Discovering something new is also fairly strong. And the average investment per innovation was $7.7 million for the financial innovation ones, which was a surprise to us. We assumed that industry wouldn't be investing as much as academia and so on. But as far as the innovations in industry, they were fairly high. Some of those were because they were in financial organizations in the oil and gas that were investing in very large projects. And then comparing basic versus applied, in the sample right now we have 93 basic innovations and 122 applied innovations. And this is showing the same data by sector as far as the total investment in the sample and the average amount per innovation. And here's how it splits up by industry. In this case, we are getting a number of industries that we start to have some decent sample size. But you can see the lower half of the chart, we're sitting at one data element per industry, which you cannot make any relevant comparisons yet. But as we grow the sample size, I think it'll be quite a bit stronger. Then the other important one is we want to be able to create this whole structure so that companies, countries, and organizations can do a lot of modeling and gaming of the system. For example, if you're in a certain country and you're going to invest $1 billion in HPC, where's the relevant place to place that money? And we're not quite there with the data, but we're hoping to be there maybe by the end of the second and a half year. But this shows some initial comparisons. A little surprise for us was China at the moment in our sample spends a lot per innovation. And where we're going to be drilling down on that, is that because they're actually spending a lot more per innovation, or is it because on most of the really big Chinese systems, they're only using them 5 to 7% of the time? So if you're running a job that takes 2% of the Milky Way 2, your actual funding allocation would be close to 25% of the machine. So it might be more that the cost allocation that takes place there. But that is a relevant comparison. Then looking at the different indexes, the importance index right now from a statistical viewpoint we're quite pleased with, because people are using the whole scale and roughly using a fair amount of the same amount in the scale. We were originally concerned that a lot of people would say, hey, my innovation's the best in the world, the number one. We're not having that problem of the bunching at the high end of the scale. So we're pleased with that part right now. Now, the impact scale, we're not as pleased with right now because we're having a lot of bunching at 5 here. So that's 10, it's useful to 10 organizations or more. We're probably going to have to add a couple more levels above that, where we go maybe 10 to 50, 50 to 100 on the scale. And then the average size of the HPC investments, I mentioned some parts of it, but this gives you more of a profile of how much each project is actually requiring as far as the whole thing. On the government sites, around 2.3 million. Academic sites, around 2 million per project that we have here. And like I said, this price to us, the industrial sites were quite a bit higher at 5.3 million. And just some notes about the data. We do still have some outliers in the data. Now, the outliers are real data points. The amount of data points we collected to create this data, we actually threw out about 1 for every one we kept. But these 2 data points we still have not put into the structure because there are 2 organizations, financial institutions, that actually got $12,000 return for every dollar they put in HPC, and the other was about $9,000. If we include just those 2 in the sample, it increases that 540 ROI to something over 750. And we'll be including those in once we get a bigger data set, unless they continue to be truly unique outliers. And as I mentioned earlier, you can download everything from this website. You just use the user forum /ROI. The full report is like a 100-page document. The ROI models are the Excel spreadsheets. You get the whole database we're making available to the world. And then also in the HPC success stories there, we created a separate document where we tried to profile about 18 of the success stories. And this was designed for Congress, to make the case for exascale. You can see in the title, real world examples as a prelude to exascale. But we basically set it up so you have a one-page summary for those that only want to read one page. And then there's a two-page executive summary. And then we go into 2 pages for each example. And let me just, here's the table of contents. The examples are sorted, into these categories: improving the health care and quality of life, reducing fuel cost and carbon emissions, improving manufacturing and global competitiveness, and then innovative disaster mitigation and recovery. So we kind of put them in those broad categories. And so just in summary, the results that ROI is very high with HPC. The results continue to actually grow in the studies we did. I should mention in the pilot study we were at 357. We also did a study of Europe only that was slightly higher. That was getting closer to 400, and now we're at 514. Our expectation was originally that the number would actually cascade down because the initial data points we get are most likely the most successful cases. And then as you get additional data points, they're probably not quite as successful. So we haven't hit that tipping point yet at this stage. And the other last point I want to mention here, that the outcome of this research is also a very expansive list of HPC success stories. So if somebody wants a success story, in the bio-life sciences or in the financial or whatever the sector is, you can sort the data and get a whole category of success stories. And if you have any additional questions, feel free to email us or check out the website, as I mentioned. And we'll take a break then. And the other thing I should mention is HP is having a drawing for a tablet. So make sure you put your business card in the little fishbowl in the corner there. And so we'll take a half-hour break. Great, thanks.